In all of our other videos, we have been talking about how to describe information that we're given, whether it be graphically or with probabilities or even with our confidence intervals. What we're going to start discussing now is what we call hypothesis testing. This is actually the decision-making process for evaluating claims about a population. This is where we put everything together and actually do the inferential statistics and make inferences back about the population and actually make those decisions. Is it a good claim or is it not? So we need to go through a couple of items first. In hypothesis testing, we have two different types of hypotheses. And we'll have each of these hypotheses in all hypothesis testing. The first is what we call the null hypothesis. The null hypothesis is a statistical hypothesis that states there is no difference between a parameter and a specific value, or that there's no difference between two parameters. It's denoted by H naught. In what we're looking at, for the most part, it's going to be H naught mu is equal to some number, meaning that there's no difference between the mean and a certain number. This is always going to be our null hypothesis that we're looking at this point. Make sure that you put the H naught and the mu in here. It's not H naught equals, it's that the mean equals, okay? So this entire thing is your null hypothesis. The second hypothesis that you're going to have is what we call the alternative hypothesis. In other words, like in a courtroom, you have the prosecutor and the defense. So one will be the prosecutor, one will be the defense. And that's the same thing in hypothesis testing. You'll have the null hypothesis and then the alternative hypothesis. The alternative hypothesis basically states that there is a difference. Some type of difference. It could be a less than, it could be a greater than, or it could be just that there's a difference, not equal to. We denote this with an H1, meaning that it's not the null hypothesis. And there's three different types that we'll have. We'll have the alternative hypothesis, mu is greater than some number, or we could have that the alternative, the mean is less than a number, or we can have that the alternative, the mean is not equal to some number. The not equal to just means that they're stating that there is a difference between the two items. Not that it's equal to or anything. In the table here, I have given what we call the three possibilities. We have a two-tailed test, and that is where the null hypothesis is equal to some number, k, and k just means the proposed value, and that the alternative hypothesis is not equal to. So when we go to draw our picture, our standard normal curve, which we will do in all of these, for a two-tailed test, of course, we will have two tails shaded in because it's not equal to. This is the part that would be considered the null hypothesis area, and the tails are the alternative hypothesis area. For a right-tailed test, these are the greater than. Notice my null hypotheses always are the same. It's the alternative hypotheses that differ. So for a right-tailed test, my picture would look like this, only the right-tailed is shaded in. So this portion that's unshaded is going to be my null hypothesis area, and the part that's shaded is going to be my alternative hypothesis area. Then we have the left-tailed test area, which of course is just going to be the opposite. And we have the left tail shaded in. So you have to, again, just like we did in previous videos, make sure you're reading which area that you're shading in and pay attention to this. One thing that we have to still pay attention to is the level of significance. We have looked at this level of significance before with our alpha in the confidence intervals. It's the same type of alpha, it's just here we're looking at it as being the whole thing if it's a right-tailed or left-tailed. Then we look at the critical region. It's also known as the rejection region. It's the range of values of the test value that indicates that there is a significant difference and the null hypothesis should be rejected. So what it is when we draw our pictures, like a moment ago, if I have my left-tailed test here, the shaded area here is considered the critical region. This is the critical region, also known as the rejection region. So if a value falls in the rejection region, we're going to reject it. What we do is we have to look up our alpha again on our standard normal curve in here and find the z value that corresponds to it. So let's say that our alpha is equal to 0.05. Let me make that look a little bit better. 0.05 for a left-tailed test. Okay, so that would mean that I would draw my picture and I would put 0.05 here. So since it's for a left-tailed test, I look it up in the center of my chart here and I find 0.05. Well, notice here's 0.03, here's 0.05. Oh, here I am, and it's right in between these two numbers. So let me circle. We're right here in between these two numbers. Remember I said we always take the one to the left if it's exactly between. So I follow that out. Negative 1.64. So that is my z that corresponds to this. This z right here is what we call our critical value. So the z is the critical value that we look for. Once we have looked up the alpha in the center of our chart, that gives us our critical value. Let's try another one. Let's say that we have a alpha equal to 0.10 for a right-tailed test. And we want to know the critical value for it. Well, the first thing I'm going to do is I'm going to draw my picture. And since it's for a right-tailed, I'm going to draw over here. Okay. And I'm going to put the entire 0.10 in there. Now remember that the chart only gives us to the left. So the chart only gives us to the left. So if 0.10 is to the right, this is 1 minus 0.10, which is 0.90. And this is what I look up in the center of my chart. So let's come up here to the center of my chart, and I'm looking at 0.90. Well, here's 0.8, here's a 0.9, and here's a 0.8, here's where it changes to 0.9, and I'll look and see which one it's closest to, and it looks like it's closest to this one, 0.8997. And if I follow that over, that is a 1.2, and I can follow that up to an 8. So my critical value, Z, is a 1.28. And most of the time wherever I put it on my chart, I will put critical value as 1.28. Because later on we will actually be calculating a Z for a test value, and so we'll want to know exactly which one's the critical value and which one's the test value. So I'll always want to put that this one is the critical value, CV, for critical value. Let's try one more, and that's if I have an alpha equal to 0.05 for a two-tailed test. This way you can see how we do each one of these. For a two-tailed test, this is where it gets a little bit trickier. I have to put a tail on each side, and I can't put 0.05 in both tails because that would be too much. I would have too much of an alpha. This is where, if it's a two-tailed test, I have to put alpha divided by 2 because of the two-tailed test. So if I do alpha divided by 2, that's 0.05 divided by 2, which gives me 0.025. So I have 0.025 in both sides. A two-tailed test is similar to your confidence intervals, where we have to divide our alpha and put it in both sides. Now, since I have this on the left-hand side, I can look up the left-hand side, and my critical values will be the exact same. I will use a positive and a negative version of it, just like I do for the confidence intervals. So for a two-tailed test, you'll be using it just like you do for a confidence interval. Make sure you have a positive and a negative of that. So I come back up to my table, and I want to look up for a 0.025. So I'm looking here, 0.02, and right here is 0.025. So I have 0.025, and I follow it. That's a negative 1.9 6. So my critical values are negative 1.96 and a positive 1.96. So wherever it's a two-tailed, I'm going to have the exact same z value, just one is positive, one is negative. But I have to remember to divide my alpha by 2 because I am putting it into two tails. Now then, for the actual hypothesis testing, let's go ahead and walk through the rules of it and the steps of it. The first step is always to state your hypotheses, the null and the alternative. And you also want to identify the claim. This is very important. You want to identify which one is going to be the claim. You have to read the problems very carefully, but identifying the claim will help you make the decisions and summarize the results later. So go ahead and identify the claim when you're doing the hypotheses. Then you want to draw the normal distribution and place the critical regions on there, just like we were doing just a moment ago, putting the alpha in whichever side it was, shade that area. Then you want to find those critical values. The critical value, which was the z that we looked up on the table. Then we're going to compute the test statistic. The test statistic is a z, and it's the sample mean z. So it's going to be this z formula that we have right here, because we're usually going to have a sample size and everything, so we're going to use this for our hypothesis testing test statistic. Then we want to make the decision to reject or not reject the null hypothesis. Now then, here's the thing about rejecting or not rejecting the null hypothesis. If I draw my picture, and here's my shaded region. Remember I said that this was the critical region? I also said that this was known as the rejection region. So if your test statistic falls in the shaded, so if test statistic, and that needs to be written correctly, statistic is in the shaded region, then we reject the null hypothesis, because again, that is considered your rejection region. If the test statistic is not in the shaded region, then do not reject the null hypothesis. Key here, not in shaded, not reject. So this will help you make your decision for number 5, whether to reject or not reject. The last step is to summarize your results, applying them back to the problem. Do you support the claim? Do you not support the claim? And a lot of that will depend on whether your claim was the null hypothesis or the alternative hypothesis. And so that's going to be something that we're going to look at in future video. What we need to really do here is make sure that you're concentrating on setting up your hypotheses correctly and things of that nature. Practice these, and if you have questions, please let me know.